So we're gonna do answers to our review sheet. Let's do number 1. How much greater is negative 73 and a half? How much greater than negative 73 and a half is 14 and 3/4? The first thing you're gonna do is if you don't understand, draw a picture. Let's just draw a number line. Try and figure out what is going on here. Here is 0, and way down over here is negative 73 and a half. And way down over here is 14 and 3/4. Now, I taught you all types of funny ways to add and subtract fractions, right? But this is, when you get to a test, be crafty. You know what that means? Think outside the box a little bit. Take a look at those numbers. Could you make them easier to deal with, considering it's a multiple choice question? Take a look. Right now, they're in mixed number form. Is there another way to look at them? Christian, what are you thinking, buddy? What's up? Even easier. Even easier. The easiest of all ways. Yeah, decimal. Negative 73 and a half. How much is that as a decimal? Yeah, negative 73.5. Ooh, that's a lot easier to look at. And 14 and 3/4. How much is that as a decimal? Yes, 0.75. That'll help. That'll help. And so now, how much greater? You need to find the distance in between. That's what it's asking for. How much greater? So, what do we use to find distance? Some people don't remember this. You use the absolute value. Subtract the two quantities. Subtraction finds the space between two numbers, always. Like 7 minus 3, how much is that? 4. And the space between 7 and 3 is 4 spots. That's what subtraction does. That's its only purpose. So we want to find the space between these two numbers, and then we don't want a direction, a positive or a negative. We just want to know how big it is. What's negative 73 minus 14.75? Absolutely. Absolutely. So we got the absolute value of negative 88.25, right? That is not, 14.75 isn't bigger by negative 88. What's it bigger by? 88. It is 88.25 bigger. Does that make sense to you? It does? If it doesn't make sense to anybody else, I could show you another way, but otherwise we'll stick with this. Okay. Oh my gosh, 2. Who needs help with 2? What's that word decreased by mean? Yeah, 12 decreased by negative 7. So part of this test is going to be reading. What happens when you have two subtraction symbols next to each other like that? You know this. That is just 19. 3. All right. Oh my God, crazy looking problem. Crazy, ridiculous, right? Oh, come on. Ridiculous. What do you do first? What are we doing first? What's up? Angeli? Yeah, the fractional part. Let's get that out of the way, right? 108 plus 12 is how much? 120. So now we got 120 divided by 30 plus 5 times 9 minus 6. And then what are we going to do next? Let's just finish that part off. How much is 120 divided by 30? 4. Very nice. So this is going to be 4 plus 5 times 9 minus 6. All we really did was attack this part first, and we simplified it. Okay. Now what do we do next? Yes, very nice. So this is going to be 4 plus 45 minus 6. We got to do the multiplication next because of PEMDAS. And then finally, all we're going to do is just, add and subtract them. So 4 plus 45 is 49. 49 minus 6, 43. Find the LCM of 3, 8, 9, and 12. I'm not going to lie. When I was working this out last night, there really is no other easy way other than you just to play around with your calculator. That'll be needed sometime in this class. So let's start to think of some numbers. I mean, like multiples of 3. 3 times 12 is what? 36. Does 8 and 9 go into 36? No, that's messed up. Let's try something bigger. Let's try, oh, I don't know, 8 and 12. You understand what I'm doing? I'm multiplying two of the numbers together because then I know two of them go in, hoping that a third will go in and a fourth will go in. Okay? That's my kind of like my strategy. So let's see. Maybe I'll randomly come up upon it. The first thing I did was do 3 times 12, right? 3 and 12 both go into 36. All I'd have to do is check to see if 8 and 9 go in. 36 divided by 8 doesn't work. We need to get a whole number. Let's try 8 times 12. It's what? It's 72 is the number? Let's see. How'd you get 72? Was it one of the numbers being multiplied together, or it was something random in between? It's just something random in between. Sometimes that happens also as well. Let's see. 72 divided by 12. Yep. 72 divided by 9. Yep. 72 divided by 8. Woo, yeah. 72 divided by 3. Nice. So the LCM is 72. That one's just a guessing game. And that one's hard. 5. Great question. Great question. To multiply a half times 2/3, Ricky did this. I mean, that's some crazy stuff. What is he doing? He's multiplying fractions, but take a look. He starts with a half times 2/3, and then he somehow makes that 3 over 6 and 4 over 6. Yeah, he tried to get common denominators. So what do you think? Why is Ricky's work wrong, Cynthia? Yeah, okay, so his work is incorrect. Let me give you the right answer for why. Incorrect because you don't need common denominators to multiply fractions. To multiply fractions. Nope, you don't need common denominators to multiply fractions. And now let's do it the right way, right? You got a half, you got a third, oh, sorry, a half times 2/3, and that's just going to be top times top. Whoops. Let me write it out as you would see it. 1 times 2 over 2 times 3, which is 2 over 6, which is how much, Cynthia? Reduce the, yeah, 1/3. Excellent. Great job. That's really what the answer should be. Okay, all right. So a college professor has 160 exams. He gives half the exams to his assistant. Got 160 exams. He gave half of them away to his assistant. How many did he give to his assistant? 80. 80 exams, 80 given to assistant. Eighty exams. And then his assistant was like, what? Was like, yeah, she was like, no, I have too much work to do. I got to give some of these away and make somebody else do the work, right? Of the 80 exams the assistant got, she gave 1/4 of those to a grad student. How much is 1/4 of 80? 20. 20 given to the grad student. And there's our answer. So you see I did it in steps here. Steps. 7. How could you describe this set of numbers? 3, 5, 7, 9, and that ... means it goes on forever. All these numbers are odd numbers, so we're going to cross off 2, we're going to cross off 4. Okay. Are the numbers less than 9? It's choice 1. Yeah, the odd number is greater than 1. Choice 1. Let's do 8. Manuel donates 2 books to a library every month. What's the change in number of books that Manuel has after 5 months? What's up? Which one? Do you think it's choice 1 or choice 4? Ah, man. He's donating the books. Be careful. Yeah, donating. He's giving them away. So it's negative 10. Yeah, the man's down 10 bucks. 10 bucks. Let's do this. 9. 9. Which of the following sets contains all, you got to put this at the end, all the factors of 24? All the factors of 24. So, oh, I skipped a number. Oh, damn it. Okay, all right. Anyways, 9. All the factors of 24. What does it mean to be a factor of 24? You can do what? You can go into it. You can divide evenly into 24. Which one of these choices has all the factors of 24?
3.
Yeah, choice 3. You guys are amazing. Guys, which expression is true? What are you thinking? So here are our choices. There's 3 choices on your sheet. A, whoops, A, B. Are they A, B's, and C's, or are they 1, 2s, and 3s? Man, that's messed up. 1, 2, 3, 4. Is there a choice that you can knock off? Which one do you know without doing any work? Yeah, 4, you're out. You are dumb. Silly person. How about, what about another one? You think 3? Let's see about 3. Let's see about 3. So the absolute value of negative 7 is how much? Positive 7. It's less than or equal to, what's negative 28 divided by 4? Nope. Negative 7. And the absolute value of negative 7 is how much? 7. So is 7 less than or equal to 7? Yes, because of this bottom symbol. In fact, choice 3 is correct. All right, we're on 11. 11. Mary Beth had $8.75, and then she spent $4.95. Dude, how much change has she got left? $8.75 minus $4.95. Everybody knows how to do that, right? Come on, calculator. How much is it, Ref? 360? So people got 380? Man, I can't trust you guys. Can't trust you guys. I knew it. I knew it. Should have done it on my own. Yeah, 380. You could write 3.8 or 380. That's cool. Flip them over. Whoops. We'll do it over here. 12. 12. Now there are 8 things to 12, right? I crossed one of them off. But we're going to try and find the properties. Yep. Give me a minute just to write down that, just to write them down. All right, guys. Take a look. Take a look. Take a look at that first one. Does the order of the numbers change? It goes 3, 4, 5 on either side. The only thing that changes is the parentheses. The parentheses goes with which one of those properties? Parentheses. Yeah, associative. Associative property of addition. Choice 1 is E. Choice 2, does the order change? But if it's flipped, Cynthia, did the order of the numbers switch around? Did we move things? If the order changes, which one is it? Yes, commutative. A. Choice 3. Choice 3 you might not have known. This one's a tricky one. Do you see how there's an 8 multiplying each one of those? Almost as if it had been distributed to each one of them? Guess which one it is? Tess? Yeah, it's F. Distributive. How about that fourth one? D plus 0 equals 0 plus D. And in the end, you just get D. Nope. It is the additive identity. Because basically, when you add 0 to anything, you get back that same thing. You get back that D. You know what I'm saying? Let's do 6. When you multiply something by 1, you always get the same thing. Which one do you think that one is? Angelique, excellent. H. And 7. And 7, take a look. You got two fractions and they're flipped upside down. This is a property. Yeah, multiplicative inverse. I love saying that word. And finally, that last one, commutative property of addition, D. 13, the product of two numbers with different signs are Tess. I think it is. Give me an example, Tess. Nope. That's when you add them. When you multiply them, if the two signs are different, positive times a negative is, negative times a positive is negative. Right? There's a bunch of rules that we had to learn, that we learned. And I gave you like, bad thing happens to a good person. What is it? It's negative or bad, right? I hear what you're saying, yeah. What about, wait, oh, same thing equals same thing, basically? Guys, which one of those guys is an irrational number? An irrational number has no pattern and it doesn't ever end. So which one do you think? Yeah, choice 1. The problem, the reason why it's not choice 4 is because do you see how they put a bar over all that stuff? Those just constantly repeat. Although there is no pattern to those 6 numbers, those 6 numbers will keep going together as a group. That's a pattern. That's what that bar means. I'm glad we got to 15 because 16 is really easy. I want to do 15 right before our bell rings. You got negative 3/2 plus 2 1/8. I am looking, you see how it says explain each step used in your calculation? You cannot just write, I plugged it into the calculator, all right? We're not going to do that. We got to actually do the work. Here's what you do. You need to convert these into mixed numbers. 2 times 3 plus 1, 7. So this is going to be negative 7 over 2. Plus 8 times 2 plus 1, 17 over 8. Convert to improper fraction. Whoa. Okay. The next step, what are we going to do? Why can't you add these two denominators? They're different. We've got to create equivalent denominators. And so what is the least common multiple of 2 and 8? 8. 8. And what would you have to multiply the thing on the left by to get to be 8? Multiply it by 4. So we're going to multiply. Originally you have 7 over 2. We're going to multiply it by 4. Right? Times by 4 times by 4. We still have the negative out over here. Okay? And we're going to keep this guy the same. And all of a sudden you're going to get what? Negative 28 over 8 plus 17 over 8. So this is create equivalent. Whoa. Create equivalent fractions with common denominators. Oh, common denominators. Whoa. All right. Now that they have common denominators, all we're going to do is just add them and simplify. What's negative 28 plus 17? Yeah, very nice. Negative 11 over 8. Add and simplify.